you, as a student, maybe you guys are better students than I was. So I used to always think, God, they're going on and on about this. I wish they'd shut up already. And then you find out later, it's actually super important. Triangle inequality is one of those things. Yeah, I'm not a very mature person even now. If he's talking about eigenvalues, pay attention. That's like super, super, super important. It's like the best thing in linear algebra. It comes at the end, but it's super, super important. It's what runs our televisions. It's what runs your little watches. All of that is eigenvalues. It's used everywhere, and it's the most beautiful thing in pure mathematics ever. It's like so gorgeous. Anyways, pay attention to that. Pay attention to triangle inequality. Triangle inequality is the absolute greatest thing for real analysis. And Hilbert spaces becomes really important. Okay, so I mentioned this already. I'm going to take this notion of size and distance and abstract it. You already have that. In fact, in 205 and 255, we all often get people screwing up the magnitude and talking about it as if it were absolute value of numbers. It's not, right? You have vectors, and it's not quite the same thing. And so people will mess that up. And in fact, you might be talking about this in linear algebra too. We will come back to that. That's coming, and it is really, really cool. It is so cool. We're getting to the stuff I really, really love. But I'm going to first show you how triangle inequality is used in some convergence proofs. And before you ask me, how did you know to do these things? I've seen it before. So some tricks you've seen before, you mess them up, and then someone shows you the trick, and then you remember it. So it's not because of some genius that I know this. Here's an example. This is in Stewart. If you have two sequences, and they both converge, you know both of them are convergent. So I know that one of them converges to A and the other one converges to B. Prove, this seems so obvious, but prove that the limit of the product is the product of the limits. So in Stewart, they have these list of properties in the blue boxes that they'll say, okay, these properties of limits of sequences, it's there. And he has the proof in there. I don't know what kind of proof it is. It's probably not a long, well drawn out proof, but it's there. All right, we're going to do this. How do we have to do this? Can we go, I got a good feeling about this, I think it's right? Is that a proof? Not a proof. We're well beyond that. So we have to use the definition of limit. Remember, mathematicians don't have feelings. So I'll wait till Stan stops writing. All right, do break this up because I'm talking a lot, so break it up and ask questions. You must use the definition. Oh, I have a greater than or equal to. It doesn't matter. Let n be n plus 1. So that's the definition. Given epsilon bigger than 0, I must produce for u an n. That's always the same. The man grabs the epsilon out of the bag, and you have to find the capital N. The difference between your in-class assignment and this is that the epsilon's not told to you specifically. It's like he's hiding the epsilons from you, and you're finding that capital N. So I just put the definition down, and I substitute. I've done this several times, but when you come in for AI, I've noticed that it's not sticking. So I'll take that definition, and I'll sub in what I'm supposed to do inside that definition. So it's very clear to me what I'm supposed to do. I've got to find that guy, always. Here's the capital N. So it spells out for me what I'm supposed to do. If you realize I'm actually going right through the wiki thing. I'm just going right through it and going, what's my no? What do I have to show? I'm going through that. There's my no. I know this limit exists. And I'm going to write down what that means. I'm just going right through the proof wiki. There's nothing changed. And I I have an N1 here because I already have an N here. I don't want to abuse the notation, and I've already seen the proof. Just so you know, I don't go look up the proof. I recreate everything from scratch. You're going to see why. I came to the end of this proof and I thought, oh, I didn't actually make it look nice. And then Dr. Clark was passing by and he said, well, you can tell the students that this is, you can make it look nice. And here, because the proofs that you're going to see on the internet are going to make it so it looks nice, and you're going to go look at it and go, how the heck did they come up with this? So you'll get to see why.
What is the symbol given epsilon greater than 0, backwards E?
Oh, this one? There exists.
Okay.
And this is and sometimes I use a such that. And the only reason I'm doing that is I was using Colonel Lindquist's iPad yesterday and I had to give it back and I was rushing through. I still need to get where you got your iPad protector. I saw Colonel Lindquist had a broken pencil and I thought, okay, it's not just me. Okay, you hate me. This is what I do with the iPad. I was in a rush because I was borrowing his iPad yesterday. So is the same thing true for B's? You could even just write on your notes the same theorem, except I have an N2 because I don't want to use the N1 again. They're not the same. Every time an epsilon's given, if you have two different limits, they don't have the same N. You saw that yet on Wednesday when you did your in-class assignment. When you had two different limits, they didn't have the same capital N's. So these N's are not all the same. But it's the same definition. I just sub in what I know. Clear? And this is recorded. It's going to be available to you, so in case you missed something. All right, so what I did next is I just used, again, I'm doing these from scratch. And it's actually good, right? If you could just read it from a book, what's the point of me reading it from a book, writing it down, and then putting it on PowerPoint and showing it to you? You can just go directly to the book. Kind of stupid if I'm doing that. So you're going to see an actual, what happens. So I remembered something about, so here's my logic. I wanted to show you. So I've got this inequality, and I've got the other inequality, and I've got N1s and N2s. So the N1 tells you what threshold to chop off your sequence at. If I can squish both of these inequalities somehow below epsilon at the same time, then I could probably do some algebra and do the product, something with a product, so I end up at the end with what I want. That's my goal. So I knew that I have to go far out in the sequence so that both of them are squished below epsilon. That means I have to go to the biggest threshold. All right, if I take the smaller of the two thresholds, that's not going to work because I'm going to have some things in the other sequence that didn't make it. So I got to take the threshold up higher. So that's why I did that. I said let n be the max of n1 and n2. It wasn't enough to make things pretty at the end, but I'll show you what happens. All right, here's the trick. Here's my inequality. Here's my thing. I want to show that this is less than epsilon. The problem is I can't do anything with it. It's like the AN and BN are stuck together and the A and the B are stuck together. There's no way to factor it. So I'm going to do what's called adding a zero. You know how trivial I thought this was when I first came to West Point? I was working with a firstie on a capstone. They didn't have capstones back then. It was like the first capstones. And I was yelling at him to add a zero. And he was staring at me and he goes, plus 0. He had no idea what I was talking about. So I thought, I remembered him standing and staring there at me. And then turning around going, plus 0. And then staring back at me. This is what I wanted him to do, add and subtract the same thing. So the thing inside didn't change. Why would I do that? Well, I look at this for a while and I say, well, there's no way I can factor. That's the only thing I can do. Why don't I put something in there so I can group and factor? Somebody was saying they're not used to grouping and factoring. You learn all that in here. Like you get used to those things in here. I did that so I could factor by grouping. And I also did this because the only tool I have for absolute values is triangle inequality. That's the only real meat I have. So I plan to get the sum in there so I can split. Are we good? Trent, good? All right, now what I'm going to do, I'm going to triangle inequality that baby. My no has these guys in it. I'm trying to somehow get my no into play. That's why I'm doing the things I'm doing. And I've seen it before. Many, many times. So here's the thing. When I'm doing these proofs, I forgot how hard they were. There's like stuff you need to know. ANs are convergent. There's a theorem that says convergent sequences must be bounded. It's in Stewart, actually. All of this stuff is in Stewart. That's why the book was so heavy. Think about why. I'm going to prove it for you, but think about why. If it wasn't bounded, how could it be convergent? There's no way. So you can actually show this pretty easily. That's true because they're absolute values, right? So it doesn't matter if AN was positive or negative, it just comes out to the side. And then this is my appendix proof. There's no way that this can't happen. The ANs have to be bounded by A. If you wanna go quick on the writing, you can write this piece down and just write that all convergent sequences must be bounded. We'll go there because I can ask you a whole bunch of questions about bounded sequences.
What does bounded mean?
Bounded means that if you're graphing it, you've got two limbo bars, and the sequence must stay between. It's like the residuals; they have to stay between the 95% confidence intervals. Like they're all squished in there. So -1 to the n is a bounded sequence that doesn't converge. So just because it's bounded doesn't mean it has to converge. But if it converges, it must be bounded. Does that make sense? You can kind of think about why, but then it becomes hard to prove because the more you think about why, the easier that is, it becomes harder to prove. All right, so here we are. This is where I started. I know that sequence AN is bounded above. I know that this B is just a B, right? I could leave it at absolute value B, it doesn't matter. Could be negative, so I should actually leave the absolute value. But then I get this, which is almost epsilon. This is where I kind of went, okay, I should have made this look nicer. But I already know I'm done. Because what I've shown you is, no matter what epsilon you can give me, I can make my original absolute value small. That's what this tells me. Now, how could I have made this go away? Just choose my n, so it's the bigger of n1, n2, or 1 divided by a plus b. And then that would just go away because the n would cap it off. They can make it all look nice. So they add up to epsilon. So I was sitting with Colonel Lindquist's iPad, and I got to the end, and Dr. Clark was passing by my office, and I said, oh no, I forgot to make this work out so that it adds up exactly to epsilon. He said, oh no, it's actually a good thing for you to show your students that you'd have to actually think about how to choose things so they added up to exactly epsilon. I can choose my n to be anywhere in the sequence, so I can just choose my n so that this guy, since it's a convergent sequence, I can just squish it down even lower if I want. And since this is a convergent sequence, I can squish it down lower if I want, and then I'll just get everything to add up to epsilon. And he also mentioned, he's like, you see those professors going through the proof, and you're like, well, where did they get that from? Because you go from beginning to end, you don't see where they got that from. That's what they're doing.
How did we make the stuff that
Oh, less than epsilon? That's because they're convergent. It's my no. My no is that they're both convergent. So I know that this can be squished down below epsilon. This can be squished down below epsilon. In fact, it can be squished down as low as I want. That's why I could have chosen it to be lower than epsilon over 2a. Right, but to make all the math work out so that you get a magical epsilon at the end, I have to go far out in the sequence so that I can make these two things happen, and then they'll add up. All right, so I was working on Colonel Lindquist's OneDrive, so he decided to stick his own slide in there while I was working.